Welcome to WB Institution, an online educational lab. So today's topic is digital modulation technique. So under electronic communication, digital modulation seems to be a very interesting topic. If you understand the concept, it will be an easy thing to crack it out. So in this particular session, you'll be knowing about what is digital modulation. Under that, what are the techniques you have and what are the types. So guess we'll get into the session. Fine. In the screen, you can see some three different types, right? Yes, of course, your answer is right. The digital modulation technique includes three different types. One is going to be your amplitude shift keying, that is ASK. Second one is frequency shift keying, FSK. And finally, phase shift keying, that is your PSK. Fine. Before going into this shift keying and all, we have to know what exactly this modulation is, right? Okay, in my previous video, I have stated totally about what is modulation, what are the different types of modulations we have. So if you have not checked it, I'm going to place the link in the description box. So please go click it, check it and come back again. What is modulation? In this particular session, I'll give you some recap on what exactly a modulation is. So it is a process by which some characteristic of a carrier wave, you know what exactly a carrier wave is if you have seen that particular video which I have stated in the link. Okay, so carrier wave is varied in accordance with the modulating signal. Fine. What is this message signal, ma? That is the original signal. This can also be stated as a baseband signal, right? Message signal is the original signal, or else it is a baseband signal. It is get modulated in accordance with the carrier wave. What is a carrier wave? It is a continuous wave, continuous sinusoidal wave. This is a carrier wave. So in this, they are stating that modulation is a process in which carrier wave is varied with respect to the message wave. So this is called as modulation. Clear? Hope you understand what exactly a modulation is. Okay, we are clear what is modulation. Now getting into the next topic, digital modulation. What is that digital modulation? In this modulation, the message signal, that is your modulating signal, already have stated that as your original signal. Okay, original signal. Clear? Okay, is of digital in nature. Okay, we'll be having two different signal. First one is my message signal, right? First signal, I'm going to state it as the original signal or message signal, which the signal which has to be transferred. Okay, message signal. They're stating that in this digital modulation, it will be in digital in nature. Okay, in terms of zeros and ones, 0 1 0 1 or 0 0 1, whatever the sequence is up to the. Okay, message signal is a digital signal, whereas the carrier signal is a continuous signal, that is your sinusoidal signal. It can be a continuous signal. Okay, fine. This is the nature of the signal under this digital modulation. The main important concept is message signal is a digital signal. That is very important. The underlined word under this digital modulation. Clear? Fine. So already have stated under digital modulation we'll be having three different types. You have seen it earlier. That first one we are going to deal with, amplitude shift keying. Under this topic, I have seen many students have felt difficult to draw the diagrams. To understand how to draw these diagrams, guys, if you understand, if you're clear with the concept, it will be a easy thing to crack all these graphs. I believe that at the end of the session, you will draw all the graphs by yourself, not by just copying it in your mind and pasting it in your paper. No, not like that. You are going to draw the graph by yourself at the end of the session. Okay, so let me explain all the three different types of techniques in digital modulation. So first one is your amplitude shift keying. Fine. Guys, in the digital modulation, what is your message signal? First question, what is your message signal? It is a digital signal, right? Am I right? What is your message signal? It should be a digital signal. That is your first condition. What is your second condition? Means that carrier signal. What is your carrier signal? It is a sinusoid. That is your continuous signal. Am I right? That is your carrier signal. Correct. Fine. Can you see any digital signal in this particular diagram? Yes. That is your first signal. What is a digital signal, ma? In terms of zeros and ones. Can you see any zeros and one signal over here? Yes. So first signal is your message signal. Correct. So you're going to draw your message signal in terms of zeros and ones. Fine. Done. Okay. So second signal, that is your carrier signal. That is a continuous signal. Can you see any continuous signal over here? Continuous waveform. Yes. That is your second waveform, right? This is going to be your carrier signal. Fine. Okay. The general thing. Always in the in the modulation, you'll be having two different types of signals. One is going to be your baseband or message signal. Second is your carrier signal. Okay, you have drawn everything here. Actually, what exactly this amplitude shift keying is? It is the process of the carrier signal is get modulated. The amplitude of the carrier signal. Very important point. Amplitude of the carrier signal. See, since it is a amplitude shift keying, the amplitude of the carrier signal is get shift or keyed. Okay, it is get modulated with respect to the modulating signal or else a message signal. Okay, this carrier signal is get modulated with respect to the instantaneous value of this digital signal. This process is said to be a amplitude modulation. Here the amplitude is got modulated with respect to the digital signal. Clear? Understood? Fine. Now I'm going to draw the output waveform. So final third one is going to be your output waveform. So have I got my output? Okay, let me make it clear. So if you we have to compare all the first two signals. Okay, fine. So in the first signal, you can find zeros and ones. Next major concept what you have to understand in this amplitude shift keying is that when the signal is 1, okay, the digital signal is 1, in the output the signal is transmitted. Okay, the signal is transmitted. Okay, this is the keyword. When my digital signal is 0, the output signal is not transmitted. Clear? This is going to be your keyword. Okay, digital signal. Fine. When my digital signal is 1, the output signal is transmitted. When my digital signal is 0, the output signal is not transmitted. Understood? Fine. Now getting into the comparison, I'm going to compare my digital signal is 1. I'm stating that the output signal is transmitted. What sort of output signal is transmitted? The carrier sort of. See, under this 1, what is your carrier signal? That is got transmitted over here. Understood? Understood? So next, going for your 0. When it is 0, no signal is transmitted. Can you understand? Yes, again. So you can see a 2, for a 2 waves, you can see 1. Okay, so the entire segment is stated as 1. Fine. So the entire signal of your carrier wave is got transmitted in your output. The next wave goes to 0, right? So the entire signal is not transmitted. Again 1, it is transmitted. Again 0, it is not transmitted. 1 transmitted. Have you understood? Are you clear with this? Yes. So this is what amplitude shift keying is. Okay, next up. So here comes the frequency shift keying. So again the concept is similar. In the first case, the amplitude of the carrier wave is modulated with respect to your message signal, whereas here the frequency of the carrier wave is modulated with respect to the digital waveform. Okay, fine. So as usual, we have to find your message signal as well as your carrier signal. What is your message signal, ma? It is your zeros and ones. That is your digital signal is your message signal. Okay, can you see any digital signal over here? Yes, that is your first signal. So this is 1 0 1 0. Okay, 1. This is going to be my message signal. Am I right? Yes, guys? Fine. So, yes, now I have to check my carrier signal. What sort of signal is your carrier signal? It is a sinusoidal signal, or else it is a continuous signal. You can see it is a continuous signal. Can you find any continuous signal over here? Yes, your second signal seems to be continuous. So I'm going to state this as a carrier signal. Fine. Now I'm going to draw my final output diagram, that is your frequency shift keying. In this concept, the frequency of the carrier wave, this is your carrier wave, right? The frequency of this carrier wave is keyed or shift or tuned or modulated with respect to your message signal. So that is said to be your frequency shift keying. So we'll see what is happening. Let me get into the mantras. Okay, first mantra under this frequency shift keying is on when one is transmitted. Okay, when digital signal 1 is transmitted in the output area, the signal has a higher frequency. High frequency signal is transmitted in my output. Clear? My second mantra is going to be when 0 is transmitted in the output area, I can find a low frequency signal. This is going to be your 2 mantras under this frequency shift keying. Clear? Fine. Now let me check with respect to the graphs. So this is going to be my 2 input graphs, right? So when 1 is transmitted, what is your mantra? Output will be a high frequency signal. Can you find a high frequency signal at the output? This is going to be output. This is the, see, let me change the color so that you'll be understanding. Okay, now let me go with this yellow. Okay, see, this area is a am I doing it right? Okay, this part. Okay, exactly this part. Okay, fine. The first dotted lines, that is going to be your 1, right? The entire at that 1 cycle, you can see the carrier signal, the frequency is said to be high. Okay, the frequency is said to be high. Why? Because the digital signal 1 is transmitted. Got it? Second, when my digital signal, when 0 is transmitted, okay, in the second case 0 is transmitting, under this condition I will get an output of lower frequency with respect to the carrier signal. Can you find a lower frequency, that is elaborated signal, right? So this is called as a low frequency signal. Clear? Low frequency signal. This is a major variation under this frequency shift keying, right? Added frequency shift keying is analogous to the FM modulation, right? In the previous case, amplitude shift keying is analog to AM modulation, right? In the phase also, phase shift keying is analog to phase modulation. Fine. Now, did you understand it? Again, 1 is transmitted. If my 1 is transmitted, again I'll be getting the output as a higher frequency. Can you find a higher frequency over here? Yes, this is going to be a higher frequency network, right? Again, 0 is transmitted, my signal is got elaborated. Okay, see, you can divide like this. Hope you understand what exactly the frequency shift keying is. Okay, fine. So final technique is going to be your phase shift keying. So under this, the phase of the carrier signal is got modulated, shifted or keyed with respect to the instantaneous value of a digital message signal. Clear? Clear? Yes. What is your so in this technique, what are the waveform we have to obtain? First is going to be your message signal. What is your message signal, ma? It is a digital signal. Can you see any digital signal over here? Yes. First signal is your message signal, right? It is a digital signal, right? Okay, zeros and ones. Fine. What is your second signal? Carrier signal. That should be your continuous signal, right? Sinusoidal signal. Can you see any continuous signal over here? Yes. The second signal is going to be the carrier signal, right? Fine. Now we have got some sort of beautiful graph as an output. We have to know what is happening here, right, in order to draw this. Fine. See, in this we'll be having only one mantra. What is that mantra is? When there is a transmission from 0 to 1 or 1 to 0, at the phase of the carrier frequency, it will show a phase shift of 180 degrees. Okay, it shows a phase shift of what shows? Carrier signal shows a phase shift of 180 degree. Understood? This is the only one mantra under this phase shift keying. We'll check it out here by comparing your message signal as well as your carrier signal. Fine. So let me separate these zeros and ones. Okay, ma? This is going to be mine. One area. Okay, I didn't draw the output properly. Okay. Okay, this is going to be your zero pattern. Fine. This is your one segment. Okay, this is again your zero segment. Okay, fine. Okay, what have stated? When there is a transmission from 0 to 1 or else 1 to 0, there is a phase shift in the carrier signal of 180 degree. That is your mantra, right? So can you see, when the digital signal is transmitted from 1 to 0 coming to your output, you can see a signal which is showing a W-like structure. Can you see that? A W-like structure. This one, ma, this area. Okay, this is the phase shift area, means that from this point, from 1 to 0, it has got tilted. Okay, at this, actually the signal has to come like this. Okay, the signal has to come like this, right? But it has started again in the, it shows a W-like structure. Why? Because it is showing a phase shift of 180 under this area. Okay, because of the phase shift of 180 degree, the wave is again starting like a W over here. Got it? Now the next transition from 0 to 1. Okay, 0 to 1, again the upper area you can see some M like thing. Okay, at this point actually the signal has to come like this down, right? But because of the phase shift of 180 degree, the signal is starting again from here itself. Did you understand? Did you understand the background behind this beautiful graph, right? Okay, again when the transmission is from 1 to 0, again the signal is giving a 180 degrees. So these are the phase shift areas. This is the phase shift area, and again this is the phase shift area of an 80 degrees. Clear? This is totally about phase shift keying. Hope you understand what is digital modulation is, what are its types. That is amplitude shift keying, frequency shift keying, and phase shift keying. Hope this video might be very helpful for you guys. For any detailed verification or any doubts, please write your ideas in the comment section, so we'll get to know. Thank you.